Alright, example 2 says it's given that we have 3 to the 2x plus 4 times 5 to the x minus 2 equals 27 to the x times 5 to the 2x. So, a couple of things we want to do right off the bat. Number one, we want to try to get everything into have the same base. So, you know, we want our bases the same. And then we want to break apart our exponents. We want to get rid of any terms that have real values to them. And so, we'll show you the terms that have real values here as this plus 4 and negative 2. So what do those actually mean? Well, when we add exponents, that's actually like multiplying. So this 3 to the 2x plus 4 actually is the same thing as 3 to the 2x times 3 to the 4. So that's going to be important, and we'll see where this comes from in just a second. Then we have 5 to the x minus 2. So what does the minus 2 mean? Well, that's, if we can think about it the same way, this is the same thing as 5 to the x times 5 to the negative 2. You could also divide by 5 to the 2. This is going to equal, now, we want to change 27 to have the same power as 3, to have the same base as 3. Well, if we look over on the side, so like 3 to the first is the same thing as 3. 3 squared is the same thing as 9. 3 cubed is the same thing as 27. So we can actually rewrite this as 3 cubed, right? So 27 is the same thing as 3 cubed, and it's still to the x. And we're going to multiply this by 5 to the 2x. Okay, so going from here, we're trying ultimately to evaluate 15 to the x. So we're going to try and get all of, we're going to try to get all of these terms over to the other side, because we want to isolate any actual numbers that we have. We want to get all of the x variables on one side. So I'm going to divide it over. So I'm going to be left with 3 to the 4th, it's going to be left, times 5 to the negative 2. That'll be over here. So now 3 cubed to the x makes 3 to the 3x. Remember, we multiply our exponents when we raise them. This is times 5 to the 2x. Now I'm dividing over these parts. So I'm dividing by 3 to the 2x times 5 to the x. Okay, so it may look like I've made a mess, but what I do see is happening is that if I simplify this side, I'm going to be left with something very nice. Again, because I moved all of my parts that had variable exponents to one side and everything else to the other. That's the goal here. So it's learning how to manipulate terms with exponents. And so my left side here, so 3 to the 4th. 3 to the 4th is the same thing as 81. 5 to the negative 2 is the same thing as 1 over 25. So it's 1 over 5 squared. So that equals, so if I do 3 to the 3x over 3 to the 2x, that's the same thing as 3 to the 3x minus 2x. And if I do 5 to the 2x over 5 to the x, it's the same thing as 5 to the 2x minus x. And so, what I'm left with now is 81 over 25 equals 3 to the x times 5 to the x. Which luckily for me, remember, if we have the same exponents, okay, with different bases, we can multiply those bases together. And this is actually 15 to the x. So we know that 15